So we're going to start off this week by finishing up what we were kind of in the middle of last week, which is law of sines. I told you guys the three types that you use law of sines for: angle, side, angle, 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 side, 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 angle. Under side, side, angle, I put an asterisk because that's the one that's tricky. You got to check for 0, 1, or 2 solutions. Now, even though this week I'm only teaching you the 0 and 2 solution, I may put one of the 1 solutions on the test as well. Okay, just to remember what we did with that. But since we're going to review the 2 solution, that kind of reviews everything. Okay. Right. So let's take a look. So one way to tell if a problem is law of sines is to draw it out and look at the triangle and see if it's one of the 3 types that I wrote down. So what are the names of the letters we use for the sides? For sides, ABC. And then the angles, alpha, beta, gamma. So A always goes across from alpha. B always goes across from beta. C across from gamma. Based on the 3 things I circled, what kind of triangle is that? Side, side, angle. You know 2 sides and you know an angle, but the angle you know is not between the 2 sides. That would be gamma. So it is side, side, angle. If it was side, angle, side, you can't use law of sines to do it. You're going to see SAS tomorrow. The other one you'll see tomorrow is SSS. So those are the 2 cases we haven't covered yet, and that's because you need law of cosine. Okay, now, when you have this type of problem, you have to solve for something first. No choices. What do you have to find first? Beta. And then once you have beta, what will that allow you to find? Then you can get gamma. Then you can finish up and get C. Now, I wrote the box a little bit bigger just in case there's 2 answers. I'll write one in the top, one in the bottom. All right, so let's set it up to find beta. Not going to use the last row at all because there's nothing in it. So Skylar, when I set up my proportion to find beta, what could I put on the left?
Sine of 35 over 6.
Yep. Sine of 35 over 6. In fact, you're going to do exactly the same thing when you find gamma. Sine 35 over 6. Now we'll fill in on the right. Peregrine, what's going to go on the right side?
B sine alpha?
So it's got to be a fraction. Something in the top, something in the bottom. So think about how we set up the left side, and it's going to be set up the same way on the right, except with row 2.
Sine beta over.
Yep, and what is B?
B is 8.
Okay, so sine beta over 8. Now, normally I would cross multiply, but I just need to multiply both sides by 8. And that'll get sine beta by itself. What could you do on the right side if you wanted, but we're just going to use a calculator, so it doesn't really matter. Oh, I'm sorry, left side. What could you do on the left side if you wanted? Yeah.
Reduce.
Yeah, you could reduce 8/6 to 4/3. You're just going to type it in. So whether you press an 8 and a 6 or a 4 and a 3, doesn't matter. Okay. Now we want to get rid of sine. So how do we get rid of sine?
Inverse sine.
Inverse sine. Take the inverse sine of what's on the right. Again, no multiplication happening at all. Just taking the inverse sine and take the inverse sine. Now, when we type that in, as long as you type it correct, you're either going to get one or 2 things that happens. A number comes up on the screen, which means you have a solution. Now check for the second one. Or you're going to get an error, which means as long as you typed it in right, it's a no solution. Okay, let's see what happens. So looking at that, what's the first thing that I need to do? Okay, so we can type all that in first, but there's something I need to do before I hit enter. I have to change to degrees. Okay, so mode, put it in degrees. Let's check the parentheses, so make sure you close it for the 35. If you don't, it's going to take the sine of 35 sixths, which is not at all what you want. You want the sine of 35 and then divide that by 6. All right, so let's see what we get. Okay, so this isn't a no solution because I just got a solution. 49.886. Now, when we're dealing with triangles, the angle has to always be between what in an obtuse triangle? Greater than this, but smaller than this.
Greater than 90, less than 100.
Well, that's an angle in an obtuse triangle that's not greater than 90. Just any angle in the triangle, not just the obtuse one. But any angle in an obtuse triangle has to be greater than 0 and less than 180. So you're dealing with angles that are in quadrant 1 and quadrant 2. You just got quadrant 1. How do you get a quadrant 2 answer if you have the reference angle?
180 minus the reference angle.
Yep, 180 minus the reference angle. So, I'll take it backwards. 180 minus 49.886 gives me 130.114. Now, what do you have to check before you just write that down?
You have to make sure that you add that by 35, that it's not greater than 180.
Right. Check with what was given. Can you fit what was given and that in the same triangle?
Yeah.
So what that means is this is
Two solutions.
a two-solution problem. So what I'm going to do is call the first one beta 1 and the second one beta 2. Now, without finding anything else numerical, what else does that mean? There's 2 for gamma. And what else? 2 for C. Okay, so like I said before, I don't think it's harder, it's longer. You just have to do everything twice now. So what we're really doing is we're using the same table to solve 2 totally different problems.
So there's not 2 for alpha?
No, because that was given.
Oh.
Yep.
Okay.
The stuff that was given, you only have 1.
And if it wasn't given, then like even though that's a side, there's going to be 2.
Yes. And another way to think of it, if you kind of want to classify what we're doing, the 2 problems here, we'll call it like the red triangle and the green triangle. Alpha is in the red problem. Beta 1 is in the red problem. Gamma 1 is part of the red problem. The other problem we're doing, we'll call it the green problem. Alpha is in the green problem too. Beta 2 is in the green problem. And gamma 2 is the green problem. So you should have 3 green and 3 red. Those are the 3 angles in one problem and the 3 angles in the other. Same with the sides. A is in the red problem. B is in the red problem. C1 is in the red problem. A is also in the green. B is in the green. C2 is in the green. So everything that was given is shared between the 2. Everything that you have to find is in separate triangles. And what I'm going to do is I'm going to try to sketch this in a second. I'll physically draw a triangle where I give you 2 sides and 1 angle the same and show you how you can draw 2 different triangles. We'll do that after. Okay, so any question on how we got beta 2 and how we determine that it works? All right, so now what can I find? Yeah, gamma 1 and gamma 2. Riley, how would you get gamma 1?
Add beta 1 and alpha, and then subtract that from 180.
Yep. So we're going to take beta 1. Beta 1 plus alpha. Add those up and subtract from 180. So that gives me 95.114. Now, if you want, you can go ahead and do C1 right now as well. Okay, but while I'm doing the angles, I just like to finish those off. Jaylees, how would I get gamma 2?
You'll have like beta 2.
Yep. So that one I can just do, that's 165.114. 0.11, oops. 180 minus 165.114. And we get 14.886. Okay. Any question on gamma 2? Okay. Now let's find C1 or C2. That's the last thing. Doesn't matter which one you do first. So Zach, which one do you want to do first?
C1.
C1. Okay. Let's find C1. And can you set up my proportion, Zach, to do that?
Yeah, it would be sine 35 divided by 6.
Yep.
And then sine 95.114 divided by C.
Yep. C, which one?
C1.
Yep. Now, when he gave me sine of 35 over 6, technically he had two choices. He chose to solve for the side in the red problem. So he had to use a red row that was full. Well, A and alpha is a red row. B and beta 1 is a red row. Why not use B and beta 1? It wasn't given. Okay. Neither was this 95.114. But at least if we can use less stuff that was given, we're better off. Right? So that when we solve for C1, we're going to get 6 sine 95 over sine 35. Okay, I'll come back and I'll type that in a second, or if you have a calculator and do it, that's fine. Okay, now let's find C2. Right, we're going to start out with the same fraction on the left. C2 is a green row, so you have to use a green row that has everything in it. A and alpha again. So sine 35 over 6. Equals, what was, so I don't have to scroll back up, what was gamma 2? 6 over C2, and then cross multiply and get C2 by itself. So C2 is 6 sine 14, 886 over sine 35. That's a 6. Okay. Does anybody have what C1 comes out to?
C1 is 10.418.
10.418. Okay. Just to check if that's reasonable, I'm looking at A, B, and C. Out of those, C is the biggest side, so gamma 1 should be the biggest angle, and it is. And if you add any two sides together, they're bigger than the third, so looks good. And then how about C2?
2.687.
2.687. Now, if I check that one, gamma 2, beta 2, and alpha. Gamma 2 is the smallest. So out of C2, A, and B, should be the smallest. Yeah. Looks good. Okay, and that's a 2 solution problem. So if it had just been a 1 solution, all that would have been different is you would have crossed this answer out right away. You wouldn't have had to use it, and you would have just had to find gamma 1 and C1. So any question on that? Right, so what I'm going to do now is I'm just going to I'm not going to use any numbers here. I'm just going to draw two triangles that have a side, and an angle in common, but they're going to look totally different. Just like we did right here. The red triangle and the green triangle would look totally different if you drew them to scale. All right, so first thing I'm going to do is go like this. Make a copy of that. There you go. Does everybody agree that that and that are the same? Okay, so I have a side. Next thing I'm going to do is I'm going to take this side, copy it, and I'm going to flip it. By flipping it, did I change the length? No. So this is the same as that. Last thing I'm going to do is the only thing I can do is connect the bottom side, make it a triangle. Now I'm going to group it all together. And if you look closely, where is the angle that they share? Nope, not the top. Bottom left. If you line that up, line it up just right, you can see that the bottom left angle is exactly the same. So, what we've drawn is a triangle that has two sides congruent and an angle congruent, but they're not the same triangle. They're two different ones. That's the only case you could ever do that with. If you gave me two angles and a side, and you said sketch this triangle, to scale, use a protractor or whatever, you couldn't draw two different ones. Everybody's would look the same. But in this case, if I gave you side-side angle, some of you might draw the top one, some of you might draw the bottom one, and you'd both be right, because there's two angles. So any questions on that? Right, so we've done the one solution, the two solution. Let's take a look at what happens here. Now, this is also side-side angle. The quick way you can tell, you have a full row, and then you have a fully empty row. Anytime that happens, it's side-side angle, which forces you to find something first. Spencer, what am I forced to find first?
Alpha.
Yeah, I'm going to find alpha. And then once we find alpha, we can get beta. Once we get beta, we can get B if we get that far. So let's set it up to find alpha. So Megan, can you tell me what would go on the left to find alpha? Yep. Since it's just divide by 1, we technically don't even need to put divide by 1, but it's fine. Sine 50 over 1. And then Pat on the right.
You would put sine of alpha over 2.
2. And when I go to solve it and get alpha by itself, what's going to be on the left side for my formula that I got to type in?
Inverse.
Yep, inverse sine of what?
2
Two
times.
Now, inverse sine has a certain domain that you're allowed to plug in. Anybody remember when you do inverse sine, what you plug into it has to be between these two numbers? Negative 1 and 1. Yeah. So just look at 2 sine 50 for a second. 2 sine 50. Is that between negative 1 and 1? No. So if you try to do inverse sine of 2 sine 50, Ian, I didn't close my parentheses. That doesn't matter. But I get an error. Because 1.53 is not in the domain. Essentially, what you're asking is, where does the graph of sine hit 1.5? It doesn't. It only hits 1 to negative 1. So, what that means is we're done. There's no solution. Now, if you can't find a solution for alpha, then you can't add it to 50 and subtract it from 180 to get beta. And if there's no solution for beta, then you can't find B. So in terms of the time, it's the opposite of the last one. Same type of problem, very quick solution because you can't solve it. So what do you think would happen if I tried to draw this triangle, like to scale? Okay, what?
It wouldn't work.
So what would it look like?
It wouldn't be closed. It'd be an open.
Yeah, it's not going to close. So let's try to actually sketch it and see what happens. So all I need is a side that's 1 unit long and then a side 2 units long. So basically a side and one double. Doesn't matter the actual unit. So let's make something 1 unit long. And I will clone it, group it, and let's call that 2 units long. Any question on that? All right, so now A, if you were to make your triangle, A is across from alpha, B is across from beta, C is across from gamma. Fill in on that triangle what we have. Well, we've got gamma is 50. So what I've done is that's an actual 50-degree angle. I used like a protractor to sketch it. One of the things you can use on here to actually make it exact. So it worked at the time. So I use that. And A is the side that is, oh, it's up here. So the A is the side that's 2 units long. Okay, so let's take A and let's group that together, which I thought I did. I'm going to rotate it, and I have to rotate A so that it's at a 50-degree angle. That's pretty close. It's close enough. Okay, so there's A. The other side I know is C. Well, C is the side that comes off of A on the right. I can put C at any angle I want, but notice when I click here, there's a little green handle to rotate it. When I click here, it doesn't. So I don't know why, but I always have to go like this. I have to group it, and then I can erase that. And then I will have the little green handle to rotate it however I want.
How'd you figure that out?
I don't know. Just played with it one day. I said, why does this have the green handle and this one doesn't? I said, oh, the only thing I did to this one was group it with something else. So then I just grouped it. Okay, so now there's C. Now B, there's no specification on how long it is. And the angle over here, or up here, really could be anything. But it's not going to work. You can make B as long or as short as you want. No matter how long or short you make it, and no matter how you turn C, because you can change beta. That can be any angle you want right there. Will they ever connect? No. You can't. That has to stay horizontal. And that can't go more than 1 unit long. So the only way this could work is if maybe you made this angle smaller, make it like 30, then this side might reach. Or allow me to make that other side longer, and then it could reach. But one of those two things would have to change. Okay, so that's impossible. Any questions on it? All right, so the word problem. Do you want to do the mountain problem or the Coast Guard problem?
Coast Guard.
Coast Guard? Okay. Let me do the Coast Guard problem. So it's going to require making a sketch. Okay, so we're going to have to make a sketch. And the 2 Coast Guard stations, we're just going to call them Z and X, or Zulu and X-ray, and they are 120 miles apart. Now, let's say a ship sends out an SOS. Okay, so a way you could kind of visualize what's happening here is maybe there's a ship at night out in the ocean somewhere. Their radio works, but their GPS isn't working. And it's cloudy, so they can't see any stars. And since they're so far out in the ocean, they can't even really see landmarks. So there's no landmarks, there's no stars, it's nighttime, but their radio works. So they radio for help because they're not sure where they are and they just need to know which way they should go. Maybe they have a compass. So they know which direction is which, but they don't know which direction they should travel, which way land is. So they radio the Coast Guard station, and maybe, let's say the ship has a light on it. So the Coast Guard station can see the ship, maybe it's 50 miles away, but they see like a blinking light, really powerful light on top of the boat or something. They can see the boat. And what's going to happen is each station is going to see the boat coming from a certain direction. Like if you're standing in one spot and you look at something, and then somebody else is standing in another spot and looks at the same thing, you each see it from two different perspectives. Right? So there's an angle from you to what you're looking at, and then there's an angle from somebody else to what you're looking at. So, Coast Guard Station Z says, all right, we can see the boat, and looking at the compass, they're on a heading 40 degrees east of north. That's the direction they see the boat. So if north is up and down, 40 degrees to the east would be kind of like to the right of north. 40 degrees to the right of north. Now, the other station is 120 miles away. And they see the same boat, but from their perspective, the boat is to the left of north. So if they look at north, they see the boat 30 degrees to the west of north. Now, if only one Coast Guard station saw the boat, this wouldn't work. If one station could see it, all they could say is the boat is that way. We know the direction of the boat, but we can't tell you if the boat is 20 miles that way, or 30 miles, or 50 miles. All we can see is a little pinpoint of light blinking with binoculars. And that's it. We don't know how far away it is. Right? But with two stations working together, this is called triangulation. Okay, they're going to triangulate exactly where the boat is. You can do the same kind of thing with a cell phone, where instead of Coast Guard towers, you have cell phone towers, and they ping the phone, and they can measure the response time for the ping to go to your phone and then go back to the tower. And if you do that with several towers, you can triangulate the position. If you did it with just one tower, you basically would get a circle of where the person could be. That's all you would get. Like if they said, okay, it took 300 milliseconds for the ping to go out and come back, which means the person is within 3 miles of the tower. But they wouldn't know 3 miles which way. It would be like a circle with a radius of 3. Do that with several towers, and you can figure out exactly where someone is. So the question is, how far away is each station from the ship? And then that information they might use to decide, okay, it's too far to send a helicopter because it doesn't have enough fuel to get there, but we can send a boat. It'll take longer, but there's enough fuel. So that maybe they use the distance to figure out something like that. All right, so a lot of information. What do you think would be helpful to do with all this information to kind of think about it in a different way? Yeah, I'm going to draw it out. So we've got basically Coast Guard station is on land, hopefully, and the boat is out in the water. So that's going to be land. That side will be water. Here's our two Coast Guard stations. What did they tell us about them? 120, what was it? Miles. If you're wondering, well, how would you know that? Coast Guard stations are probably marked on a map. Maybe they have an address you can drive to it. So they could just easily look on a map how far apart they are. Okay, so 120 miles apart. And we've got a boat out here. There's our boat. And each station sees the boat and gives a direction as a heading from north. So what I'm going to do is draw a line that represents north for each Coast Guard station. Now, technically, I'm going to draw north-south as up and down. But really, north and south would be curved in a little because all magnetic lines meet and they all touch at the North Pole. So, we're not magnetic North Pole. But for our problem, it's okay to just draw north as vertical. keep that part simple. Okay, so we've got our two lines, north, north, and I'm going to draw a dotted line that kind of represents the beam of light coming from the boat. Now, of course, the beam goes in every direction, right? Or if it's a rotating light, eventually you'll see it from every direction. But the only two directions we care about are that direction and that direction. So really, we just made a triangle. Now we just have to figure out some angles. It's important which station is which. I think it said one of them was to the west of the other. Coast Guard Station Zulu is west of X-ray. So this is Zulu, this is X-ray. Okay. So it says the call, or you could just substitute call for the beam of light. So Coast Guard Station Zulu sees the beam of light 40 degrees east of north. So which way is that? To the right. And where would the 40 degrees go? Right, on the top, right there. Above the dotted line in between north. 40 degrees east of north. Now the other one I know is west of north, but I don't remember what it was. 30. Now, are those angles actually part of our triangle? No. What we really want is this.
Complementary angle.
Yep, complement. So I'm just going to take that triangle, move it down there. That's 120. What's this angle?
50.
50. And this angle? 60. And now the word problem part of this is done. All we have to do now is find the two sides. Because you have to find the two sides, but what else are you going to have to do?
Third angle.
You're going to need the third angle. So if you add up, 70 and 50 is 120, plus 60 is 180. The reason you need the top angle, there's your full row if you're doing the law of sines. You know an angle, and you know a side across. So there's your full row. All right. So now let's just make up a letter. A, B. A, B. It doesn't really matter what you call it. Just remember that when you set up your proportion, it's the sine of an angle divided by what's across from it. Sine of an angle divided by what's across from it. So, how would you find A? Yeah.
You would do the sine of 70 over 120.
Yep.
And then the sine of 60 over A.
60 over A. So we'll do that. And then find, what did I call the other one? B? Whatever we called it. I think it was B. Still going to use sine 70 over 120. Equals sine of, is that the other angle, 50? Okay. And now we cross multiply, and then we'll have A and B. So that's the easy part. I think the harder part is just the diagram. Okay. So what do I get? You don't have to give me the decimal yet, but when you get A by itself, what times what divide by what?
It'd be 120 times sine of 60 over sine of 70.
Yep. So type that in. That'll tell you A, which is the distance from the boat to Zulu. And for B, somebody else tell me what my formula for B would be.
120 sine 50 over sine 70.
50 over sine 70. Perfect. That's B. And that is the distance from the boat to X-ray. All right. Does anybody have what this one comes out to? The distance for A? Well, how about somebody else type in B? I'll type in A and see what I get, and then somebody else that has a calculator can type in B. Tell me what you got. So we got 120 sine 60 over sine 7. So that's 110.59 miles. And what does B come out to? 97.8. Okay. Now, in terms of like a real life problem, let's say all of a sudden the boat lost power. Okay, so they saw the boat at one point, they knew where it was, and then it lost power. What would you have to take into account now if you send a boat or a helicopter out to go rescue that boat? Yep.
Like the tide.
Yeah, you can't fly to where you saw it, because if the boat is in a current and it's moving, let's say maybe the boat travels at, 35, 40 miles an hour. I mean, that'd be pretty fast for a boat on water. So if it's traveling that long, it may take over a couple hours to get there, depending on which station it's coming from. So if you go to where the boat was 3 hours later, it could be 60 miles from where you last saw it. So then it complicates it, because now you have to take into account the tide and that it might be moving in a different direction. So that would make it very hard to find. Obviously, if the light stayed on the boat, you could just keep flying towards the light. You'd be all set. Okay. Any questions on that one? Okay. So I think normally I would do the other word problem, but I'm gonna hold off so that way we can do the two tests. Okay, so homework for tonight, page 435 in the book. So it's 4, 9, 11, 13, 14, 18, 19. Okay, so in terms of difficulty, I think today and tomorrow are pretty much the same. Wednesday and Thursday are harder.